Those are the three that we've done. Now the fourth one is on my next slide. And that fourth one, let's see here. Okay. That fourth one is known as a scatterplot. Now, the scatterplot, watch in the instructions. If they ask you for a scatterplot, these rules apply. They are going to show a relationship between two quantitative, which means I have quantities for two different characteristics of something. Now, the horizontal axis could represent one of the variables, where the vertical is going to represent the other. Now, this is most important. The points are not connected, because we have line graphs that are continuous, which was the first type of line graph we did. We connected the dots. But this one is going to bring about some discontinuous data. We can't connect them. So therefore, each dot has a value for the x and the y axis, but it has no relationship that we can connect each dot to each dot. Now, here is an example. The following scatterplot shows the relationship between horsepower and highway mileage. Well, every increment of horsepower is not the same thing as highway mileage. Now, you're going to notice on this graph that I have dots that don't connect. Okay. Now, also, neither axis starts at 0, because notice I have breaks. Now, the only thing that mathematicians can do with scatterplots is find a general pattern. The dots are either going to increase or they're going to decrease. They're going to fit a curve. They're not going to fit a curve. But there's a pattern sometimes found. Sometimes there isn't. Sometimes we talk about a trend, the movement of the dots. But these are characteristics of my scatterplot. Now, we're going to do a scatterplot. This is saying state the ordered pairs to be graphed. Well, remember, this is the x. This is the y. And remember, when I write my ordered pairs, my x will go before my y, which means that my yellow, didn't want to do that. I thought I had yellow. My yellow value, which is these values, will come first. And then my orange values will come second. So that means when I write my ordered pairs, it will be 0, 5, 2, 1, and then I have 4, 3, 6, 0, 8, 7. These are my ordered pairs. The yellow number is coming first, followed by the orange dot. Now, see the graph? I'm going to graph these. Okay? So that means I am going to put a dot for 0, 5. That's going to be right here. 2, 1, going to be right here. 4, 3, right there. 6, 0, right here. 8, 7, right here. Now remember, the first number is your right number. First number, I went right. Second number, I went up from where I went right. Now, it says, do the ordered pairs get connected? Well, this little word is meaning no, because in a scatter plot, the ordered pairs are not connected. The ordered pairs are not connected. Now, going on, this is going to bring in 2 more vocabulary words. These are called independent and dependent variables. Now, I like to start out with the independent variable because it sits on the horizontal, or what we call the x-axis. Now, the other one that I have is called the dependent variable. Okay. Now that is the vertical axis, or what we call the y-axis. Now, 2 variables which we just saw, the x and the y, are always going to be paired. That is part of graphing. But it is thought that one depends on the other. One depends on the other. That means I'm going to either be given or determine what is my independent variable. Now, the independent variable is normally going to be, and sometimes I like to think of this as the choice variable. And that's just like getting into your car, you turn on the engine, it revs up, and you make the choice to go fast or slow. And then, depending on your choice, the odometer reacts. which means it's going to show your speed increasing or decreasing. There is a reaction to putting and moving the car. Once you hit your foot on the pedal, you are going to get the car to move. But it's how hard you touch that gas pedal. That's your choice. And once you choose to put your foot to the floor or pedal to the metal, the car moves very slowly or very quickly. The independent is your choice. And that's what you've got to keep in mind. What is the choice? And once you decide which variable is the choice variable, then you have what we call a reaction. The odometer moves. So, with that said, here we go. Okay. Suppose you are driving 50 miles per hour. Notice mph, per hour. Now, if you travel 1 hour, then you go 60 miles per hour. If you travel 2 hours, you're going to go 120. In this sense, distance is the reaction to the choice we make about how long we are going to drive. You'll consider distance as the dependent variable. And time. Time is the choice. How long do we want to drive? That's the choice. If we only drove an hour, we're only going to go 60 miles. But if we choose to drive 2 hours, we are going to have an odometer that shows we've gone 120 miles. Now, in this case, you could also say that in order to go 60 miles, you drive an hour. To drive 120 miles, you then go 2 hours. Now, notice how I reversed it. I chose to go 60 miles. That's an hour. That's my reaction. So look at the situation, because the situations we're going to come to are going to ask us to determine the independent variable, the dependent variable. And here we go. Determine the independent and dependent variable. Now, okay, you got to kind of think of the situation. A kite can rise to a height of 25 feet when the wind is blowing 4 miles per hour to a height of 75 feet when the wind is blowing at 12 miles per hour. Okay, now, this is one that you may kind of have a little trouble with, because you're saying, what's the choice? Well, the choice is going to be the wind. Our kite is going to go up 25 feet. That's the reaction. The wind is blowing. I put my foot to the pedal in my car. That is going to have me move. But also think of height as distance. So the independent variable here is going to be the wind speed per hour. The choice of when I fly this kite. The choice of when I fly this kite. If the wind is 4 miles an hour, it's going to go 25 miles. The reaction will be it goes 25 feet. But if it's a very windy day, my kite's going to go higher. So in this case, the dependent variable is the height in feet. Okay. Now, the kite is like my car. Compare it to putting your foot to the pedal on your car, and it's then going to move. Well, when I have a kite, where I take it when the wind is blowing, the reaction is how high it goes. The more wind, the higher the kite. Hopefully that makes sense to you. If not, you're going to kind of have to think about this a little bit because the dependent variable was the height. The more wind, the higher the kite. Maybe that's easier to think about. Now, we're going to be given another situation, but a little more detail here. And some parts of it, it's already on the graph. It's just trying to figure out, do you know where these parts are found on the graph? Now, it is asking you for the independent and the dependent variable. Well, I'm given a graph. Also, it says the graph shows the hourly temperature in a city on a particular day. Okay. But if you remember a couple slides back, the independent variable is time. That's the horizontal axis. And as you saw, the dependent is the vertical axis. They gave me the graph with what I needed. I just had to know where to find it. Okay. I didn't have to figure out the story. It was on the graph, but I had to know where to find it. Now, this is another vocabulary word that you may have heard in the past, but you're going to see again. This is called a function. Okay, now a function is a graph, but, and I'm going to put it over here, to be a function, you can only have one x value to one y value, or each dot on the graph passes the vertical line test. And the vertical line test means if I draw a vertical line through any dot or ordered pair on my graph, and only one dot falls on that vertical line, it is a function. Now, the top part may not be something that you can guess right away, but in this case, to be a function, you're going to have one x value to one y value. Well, if you look at each of these dots, I can only have one time and one temperature for each of those dots. One time, let's say the one down here, and I'll make the one down here this color. That dot represents 9 a.m. and the temperature is 68 degrees. One time, one temperature. But this one is the one that most people know and recognize. It's called the vertical line test. Now, this is saying that if I draw a line through any ordered pair, there's only going to be one dot on that vertical line. Well, if I draw this line, it's vertical. The only dot on this line is that dot. The same thing as if I go over here. This is a vertical line, but I only have one dot. So in this case, is the graph a function? Yes, it is a function because each time is matched closely with exactly one temperature. Okay. And that's the catch. Each time is matched closely with exactly one temperature. Now, that's what they're going to use as the definition, time and temperature. They put them together. Now, this is one that you may find, and again, this is one of those times that they're asking you to write an interpretation. Now, the interpretation, when you get this type of question in Pearson, read all of the choices carefully, because this is a possible answer of the interpretation. The temperature mostly increases from 9 a.m. to 2 p.m. and decreases from 2 p.m. to 6 p.m. Notice the words These are the words you're going to have to watch out for. Increases, decreases. And if you look at the graph, it's increasing up to about 2 o'clock, and then it decreases. These words are part of what we call the trend. And interpretation is another way that's saying we want a trend. Okay. Now, this is something we've also been doing. When we find the independent and the dependent variable, okay, and I'll make those in yellow because that'll make life easy here. Okay. We are going to have to scale it. Now, we've talked about the scale before. Remember, they have got to be equally separated. And to scale, you're going to consider the smallest to the largest. And then you're going to choose a consistent increment. That means if it goes down to 5 and up to 25, we will go from 0 to 30, and then we break it up. Now, from 0 to 30, I could make it by 5s. I could make it by 10s. Now, I wouldn't want to make it by 8s because 0 to 8 to 16 to 24, well, it would go to 32. I'm only going from 0 to 30. I want to make sure that I have consistent, equal increments. And normally 5s, 10s, sometimes we could have done 3, 6, 9, 10, all the way up to 30. That would work, but it's your choice. And then we're going to plot each value based upon where we labeled the increments on the x and the y axis. Now remember, the independent variable is the first number, the choice. And then the dependent is the second number. Now, here we go. Now, this picture and the next one have certain points that I've got to draw out because you need to be able to read what it's asking you. And some people have trouble with this one. I'm not sure why, but maybe it's how they phrase it in English. Because once you understand it, life's nice. It says, use the scatter plot of pressure versus depth shown to the right to answer questions A and B. Okay. Now, it is saying, what is the maximum value? Okay. Okay. Maximum value for depth. Well, notice depth is our vertical axis. Question A is asking you, what is the largest x value? Maximum. On the depth is horizontal. Which dot has the largest x value? Well, hopefully you realize that it is this dot, which has a maximum depth of 7. A maximum depth of 7. How far am I going right? That's really what the question is. The maximum value of depth for depth. Depth is horizontal. Now notice how B changes. Now, this one is asking you for the maximum value for pressure. Okay, this is pressure. Question B is asking you what is the highest Y value? What is the highest Y value? Well, the highest Y value, again, comes from this point. But notice it is on and has a value of 8. So notice what it's asking you. Now I'm going to change the question a little bit. Now, here comes a different graph. We have a scatter plot. We're going to talk about light intensity versus distance. But notice how the words change. What is the minimum value for distance? Here is the distance. It is my horizontal line. Question A is asking, what is the smallest x value? The smallest x value. Well, first off, notice that this point right up here, it has a y value or an x value of 1. This particular point up here. Now, notice it's talking distance. Smallest x value. This is 1/16. The 1 is my smallest x value because as I look at my other 3 points, the x values are larger. But I want the minimum. Okay. Now, here comes B. Okay. This is asking you, in this case, for the minimum value for intensity. Well, this is intensity. Okay. Now, question B is asking, what is the smallest Y value? Smallest Y value. Well, this time it happens to be this point right here. the smallest y value is also the lowest. Now, let me see if I can make that a little better. Okay. The lowest y value. It's still 1. Maximum, minimum. You got to keep these terms in mind because as you move forward, they are going to be asking you very similar questions. Now, we're going to talk about scatter plots a little more. Now, remember you have a project coming up? If you have to make a scatter plot, you do not connect the dots. That is most important. You do not connect the dots. And again, you're going to choose the independent and dependent variable. Okay. You're going to draw and label the axes, and you're going to give it a title. Now, you're going to have to choose the minimum and maximum values. That means if my table shows or values show 5, and the next highest one is 25, I am going to do 0 to 30. 0 to 30, and then I'm going to make it into convenient increments. And I'm going to remember that the independent variable is the first one in an ordered pair. Now, when you do a scatter plot, you are going to sometimes have more than 2 columns or 2 rows in a table. And this is a perfect example. Now, this table at the right is showing the 2017 gross domestic product and percent using online social networking sites for several countries. Now, this is something you may not realize. I have 3 tables. This table right here and this table right here are going to represent a dot that represents Germany. Okay. And just to give you a little heads up, this column right here, the GDP, is going to represent my X. The green is going to be my Y or vertical, which means if this is my X and this is my Y, okay, I'm going to come back to this table a couple of times because the next couple of slides are going to deal with this table. Now, it's saying which variable shown in the table is my horizontal axis. Well, remember, I told you it was the GDP per capita. That was the second column in the table. Now, it says which variable is the independent variable. Well, it's asking you the same question. Okay. The independent variable is my X, and that X is the GDP per capita. Now you're going to say, well, why didn't they just say that in the same line? Well, A is talking about the label, and then B is talking about what am I going to use that horizontal variable as. It's going to be my X. Now, as you can guess, it's talking about the variable of the vertical axis. This is percent using online social media. Okay. That's my vertical, or the third column in my table on the last slide. And again, which variable is the dependent variable? Well, percent using online social media will be Y. The questions are basically giving the same answer, but the B and the D give you a little more detail, okay, which is what you need to keep in mind. Now, here's the fun part. That slide you gotta have in front of you, and that means, let's look at this one. Okay, we are going to be asked to find a scale and increments. Well, let's take a look at the GDP column. Now, what is the lowest number in the GDP? Well, I believe that the lowest one I have is right here, 7,200. Well, what's the highest one? Well, it's way down here. Okay, I am needing to decide how to make my increments. Well, the United States is real easy to do. This is 59,500. We are going to make this a little higher, which means we're going to go to 60,000. We always want to be a little higher. Now, in India, this is where you gotta make some choices. Well, in India, okay, if we start with 5,000, that's a little lower, we'd have to go and put a break in our graph. Remember, break, because we're not starting at 0, which is why if we can start with 0, we make life easy. So here it's saying what is the minimum value on our x-axis? Well, remember we saw 7,200, but if I make it 0, which is good because I'm not going to have to make a break on my x-axis. And my maximum, notice that I went up to 60,000 because it was 59,500. Now, this one you're going to have to be careful with because you want to either do it by 5s or 10s. it's a lot better to go smaller. But could I have said 10? Yes. Now, you don't want to do like something like every 12,000. You'll still get an answer, but you want to try and make it consistent. And if you can always start the x-axis with 0, do it. Now, let's go back. Now, we're going to go into the y category, which is the green part. Now, looking at this, what is the lowest value? Well, the lowest value is 20. What's the highest value? Well, as you can gather, it's down here. Now, 69 is very easily rounded to 70. That works. Now, 20 is a number that ends in 0. So we could start with 20. And if we do, we'll have to put a little squiggle on the x-axis. That means when I make my horizontal, my vertical will have a squiggle because I'm starting with 20. But do I have to have this squiggle? Well, that's something you're going to have to choose. Okay. Now, when we look at the graph that Pearson makes, they do put the squiggle in on the vertical axis. But to be honest, I'd rather not have squiggles. I'd rather make it 0. So when I come here, what is the minimum? Well, preferably, I like 0. That's my choice. That is also something that I prefer to do. And then what's the maximum? It's 70. And again, I want to go by 5s. Now, this is the best graph you can make. But again, Pearson draws this graph. Notice right here, they have the squiggle. Well, we would have had a lot of white space in through here because we started with 0. Because we would have had 0, 5, 10, 15, up to 20. But it's your choice. This, and notice how they labeled it. Notice that we went from 0 up through. Okay. We went from 0 to 60. That's what we said on the last slide. And we went by 5,000 when we did the vertical. Now, I preferred 0 to 70, but then here they went from 20 to 70. Your choice. But notice what each dot represents. It represents the country, because social media and GPD aren't truly related, but we're trying to give them a relationship. And in order to know what a single dot is, I have 3 columns. The dot is telling me that I can match the GDP and the time percent on social media in a dot. Okay? Now, keep that in mind when you make your graph. Now, as I said, for this slide, okay, yeah, for some reason it went away. As we said, this was 0, 60,000, and we did it by fives. Now, remember I said I prefer 0? Pearson did 20 to 70, and they did it by fives. This is the graph you see here. Now, here we go. This is a graph that you're going to need to learn to interpret. Okay. Now, this is where you got to be careful with the words. So these last couple of slides, or 3 slides, you are going to see how I interpret a situation. You are going to need to do the same. This is a skill. It says select the section. Okay, select the section of the graph, and notice they've given me A, B, C, okay, come on, Beth. C, it doesn't like me. C and D. Those are the sections of the graph of altitude in 1,000 feet versus time corresponding to a plane taking off. Now, if you close your eyes, you're on the runway. They rev up the engines, and then all of a sudden, the pilot pushes the throttle forward, and then all of a sudden you go rolling down, and then you're up in the air. And then he levels off. And as you go through the clouds, he might come down for a little bit to avoid some turbulence. He might then level off again. And then he's descending to the airport. He then goes back to the ground. Well, in this case, which section of the graph corresponds to a plane? Okay, that's where your little visualization, taking off during the first 2 hours. Well, this is my first 2 hours. This is the section I'm looking at. He's taking off. Okay. Taking off during the first 2 hours. Well, this is going to be A. He's taking off. Take off. This piece is saying he's leveling out. He's descending because of turbulence. He levels off. And then he takes and descends. The flight's over. You're back at the airport. So which section of the graph? Well, in this time, it's A. Now, This is a little different, but it's still asking you the same thing, except this time we're using a boat. Select the section of the graph of powering speed, boat power speed versus time to the boat slowing down and then holding steady. Okay, what does the question say? Which section of the graph corresponds to the boat slowing down and then holding steady? Okay, well, notice right here, he's slowing down and he's holding steady. It is in this piece that they're talking about, which is C. Here he's at the dock. To move away, he speeds up. He then travels the water at a steady speed. But from here, he slows down and he holds a steady speed. And then he decreases as he gets back into port. So the part here is C. Now, my last slide. Okay, this is where you really have to know what's going on, which means when you are given this type of problem, think about what's happening. You're trying to graph what's happening. And I'm going to give you a little kind of clue. Graph provided shows a car speed versus time. Now they want you to write a statement that best describes the scenario. Okay, right here. We're going to describe this section. Well, this section, this 0, 0 is your parked. Okay. And then what's happening? From, okay, as a car leaves its destination, it increases its speed to 20 miles per hour. It increases to 20 miles per hour. It is increasing. Notice my word? Increasing. Isn't that what this line is doing? Okay. Now, section C. Okay, here we go. That's going to be this green section. Okay. Well, how am I going to describe it? The car continues to increase its speed to 40 miles per hour and starts to decrease or slow down to 20 miles per hour. Now, it's going to increase to 40 and decrease to 20. Now, sometimes Pearson likes to say, well, they reached, there was like a crowd or something here at an hour and a half, so we had to slow down. But the key words here are increase and decrease. Now, we then have scenario 3. Well, that is this gray area. Okay. Well, notice it's a horizontal line. The car continues to move at a steady rate of 20 miles per hour for 1 hour. That's what that horizontal line is. He's staying steady. He's staying steady right here. He's not moving. It's the same speed all the way across the board for an hour. Okay. And then the last one, section 4. The car begins to reduce its speed until it reaches its destination. It begins to decrease its speed. See, we are going down. It's reducing. Now, could you say decreasing its speed? Yes. You can also say decrease. This is describing the situation. Now, when you get to these problems in Pearson, think, close your eyes, imagine what's happening that the graph is picturing. With that said, I'm signing off.